Welcome to myprojectbazaar.com. Now let me see about silhouette analysis based action recognition via exploiting human poses. Now let's have a brief explanation about the abstract. Here we propose the method to recognize the action in the silhouette of human. Here we have to extract BOCP, that is back of correlated poses. BOCP feature will extract in the sequence of steps. Initially, we extract the PCA feature. PCA stands for Principal Component Analysis. It is a mathematical procedure that uses an orthogonal transformation to convert a set of observations of possibly correlated variables into a set of values of linearly uncorrelated. After PCA feature extraction, we find the correlogram matrix. After extracting the feature, we cluster the feature by k-means clustering. Correlogram is also called as a cross correlation. It is the similarity between observation. It is used to find the repeating pattern. We reduce the correlogram dimension by the use of LDA. We extract training feature for our silhouette datasets by the BOCP feature descriptor. We train this feature by the use of SVM. SVM stands for Support Vector Machine. It is Supervised Landing Model. The training feature will give to the classifier. The classifier will train the feature to predict the result. This is the flow for project. Here we are having the two stages. First one is the training stage and then second one is the testing stage. In training stage, here we have to provide the whole dataset frames to the process. Initially we have to find the silhouette. It is the process of locating a moving object over time using a video. It is refers to mathematical methods that are aimed at detecting regions in a digital image that differs in properties such as brightness or color compared to areas surrounding those regions. Here we find the pixel variation between the two frames and we draw the block to the corresponding pixels. Finally, we track the person from the video. The tracked person is passed to the PCA feature. PCA stands for Principal Component Analysis. It is the most widely used and well-known of the standard multivariate method. PCA consists of a transformation from a space of high dimension to other with more reduced dimension. If the data are highly correlated, that is redundant information, PCA decreases the amount of redundant information by decorrelation input vectors. The input vectors with high dimension and correlated can be represented in a lower dimension space and decorrelated. It is the linear projection method to reduce the number of parameters. After extracting the PCA feature, the extracted features will pass to the k-means clustering. K-means clustering means it partitions the given data into the set of partitions. After clustering, it will pass to the correlogram. Correlogram is an image of correlation statistics. Correlogram tests whether there is a correlation between two distance matrices by measuring the correlation between each class of distance. Correlogram performs a test on each distance, the class, and generates a correlogram with distance classes on the x-axis and their corresponding mantle test statistics on the y-axis. After extracting the correlogram matrix, it will pass to the LDA dimension reduction. LDA can be seriously degraded if there are only a limited number of observations compared to the dimension of the feature space. LDA does not change the location but only tries to provide more class separability and draw a decision region between the given classes. After extracting the LDA feature, it will pass to the SVM classifier. SVM classifier is one of the supervised classifier. This is one of the kernel based technique which represent a major development in machine learning algorithm we provide our feature values to the SVM classifier. The classifier will train about the feature. After training the feature, here we have to go to the testing stage. Initially we have to provide the video frames. The provided video frames will pass to the PCA feature. That stands for Principal Component Analysis. After extracting the PCA, it will go to the clustering part. Here we are clustering the features as a set of partition. The clustering values is passed to the parallelogram matrix. Here we are finding the parallelogram matrix, and then here we have to find the LDA dimension reduction. The parallelogram matrix dimension will be reduced. After extracting the feature, it will go to the SVM classifier. The SVM classifier will predict about the result of the feature. Finally, here we are getting the result. Now let's see the execution part. Here I am having action main.m file. This is the main file. Select this file, right click, run the file. This is our guidance line. Initially here we have to provide a input video. Here we are having totally 4 videos. Now I am selecting one video as an input. The provided video will be displayed in the first axis. After read the video frames, the readed video frames will pass to the PCA feature. PCA stands for Principal Component Analysis. Here we are detecting the silk out portion in the each frames. After detecting the frames, here we are tracking that person. After extracting the PCA feature, the extracted feature will pass to the clustering. Here we are clustering the feature as a set of partition. The clustering index of the corresponding feature values will be displayed in the first table. After clustering, it will go to the parallelogram matrix. The PCA feature will go to the parallelogram matrix. Here we are finding the parallelogram matrix. Totally here we are having 112 features. This parallelogram matrix will go to the feature vectors. Here we are reducing the dimension of the feature. For that, here we are using the LDA dimension reduction method. Now let's see the result of feature vectors. This is the feature vectors. It will reduce the features as the 40. From 112, here we are reducing the feature as 40 feature. After extracting the feature, let we go see about the recognition. Here in training feature, here we have to load the whole dataset feature. In training feature, here we are having totally 252 feature as a training feature, containing the 4 dataset frames. After that, here we have to click the result. For getting the result, here we are using the SVM. SVM is the kernel based classifier. It will predict about the result of feature. Now we are having the result as bend. Now I am showing the result of silk out analysis based action recognition. It provides the better result. Thank you.